In this video, I'm going to show you how to install Tensorflow on Windows, and specifically Tensorflow with GPU support. There are quite a few requirements to get Tensorflow with GPU support working correctly, and so that's why I made this video. The first requirement is that you install CUDA Toolkit 8.0. This is not the latest version of CUDA Toolkit, but this is the version that's required to get Tensorflow with GPU support working correctly. So we're going to download this version, which is an older version. The instructions here say that you're also going to need NVIDIA drivers associated with this CUDA toolkit. Those drivers are older than the typical drivers that you would have installed on your Windows machine anyhow. So I'm going to show you a little trick on how to install the toolkit without installing those drivers, and everything should still work. Another requirement is cuDNN version 6.1. This is the deep neural network framework for CUDA. There is actually no version 6.1. There is a version 6.0. So this is a typo. We're going to install version 6.0. And again, you're going to need an NVIDIA developer account to have access to this. And of course, throughout this entire presentation, I'm going to be assuming that you've got a GPU card with the sufficient CUDA compute capabilities. In addition to these requirements, we're going to actually also install Visual Studio. And we're going to install Visual Studio version 2015 because that's the latest version that's compatible with this CUDA toolkit. Now, it's not really required to get TensorFlow working on Windows, but I like to be able to test the CUDA toolkit and make sure that that's working separately before I do the rest of the TensorFlow installation. So we're going to go ahead and download Visual Studio Community 2015 with Update 3, which is the latest version. You're probably going to want to get the 64-bit version in whatever language you like, and you'll get the exe installer and just go ahead and download that. And while we're downloading things, let's go ahead and download CUDA Toolkit 8.0. I've selected my platform, Windows, 64-bit, Windows 10. I'm going to get a local installer so I don't have to download anything else. And there's really two things that I need to download here. I need to download the base installer, which is 1.3 gigabytes, and then there's a patch that came out in June. So I'll go ahead and download both of those. The other thing we need to download from NVIDIA is cuDNN. You can see there are quite a few versions of it here. We're going to want cuDNN version 6.0, and we're going to want to make sure we get that for CUDA 8.0. So the first thing, we want to install these in the right order. The first thing that we want to install is Visual Studio, because if you install CUDA before Visual Studio, you won't get any of the CUDA extensions automatically added to Visual Studio. So the steps are install Visual Studio first, then install CUDA, then install the patch, and then the last thing we'll do is install cuDNN. So let's go ahead and get started with installing Visual Studio. After Visual Studio does some setup tasks, it's going to ask you if you want to do a default or custom install. You can go ahead and select default, and I just go ahead and choose the default install location and then hit the install button. So here's what it looks like when Visual Studio finishes installing, and you can just go ahead and click launch. But we're actually not going to use Visual Studio yet. We're going to install CUDA. So while that's off doing its own thing, we're going to open up the larger of the two CUDA files that we downloaded and get the install process started for this. Alright, first thing CUDA is going to ask you is where to store some temporary data. Just go with whatever you want here. Alright, so CUDA has unzipped all of the files necessary for installation, and it's gone ahead and checked my system for compatibility, which I didn't show you. Behind CUDA, the CUDA installer here is Visual Studio, which took its own time, about a minute or so to open up. This is what it looks like when it's running. We're going to close that now because we don't need that. So let's get rid of that, and we're just going to work on the CUDA install. So you're just going to agree and continue on the NVIDIA license agreement, and you're going to do a custom install here. So the Express install is going to install drivers and things like that, which are going to overwrite your newer drivers on your system probably. So I prefer to do a custom install. And then I'm going to uncheck everything except for CUDA. All right, this is what you want. You want CUDA checked and everything else unchecked, and then go ahead and hit next. All right, it's going to install the samples. It's going to install the CUDA documentation. It's going to install all the CUDA development tools. So hit next there. All right, CUDA's finished installing. Everything looks good here. It installed, also, this is why we want to install Visual Studio first. It installed Nsight for Visual Studio 2015. And that's nice because that gives you all the extensions to have Visual Studio 2015 compile projects, CUDA projects, and so that looks good. So we're going to go ahead and finish up this installation, and we can go ahead and launch the samples here too, so we can see where the samples are. So you see these directories contain all the CUDA samples, and we're going to end up opening up one of these CUDA samples and building it in Visual Studio. But before we do that, we want to install the patch. Remember that the CUDA download had two parts to it. It had the main installer, it had the patch. The patch is pretty quick, so let's go ahead and install that. And it's done. That was quick. So the patch is installed. All right, so we have CUDA, the patch, and Visual Studio 2015 all installed. Let's not worry about CUDA, the CUDNN stuff yet. Let's test our CUDA installation by switching back to the window that contains our samples. So here's all of our samples. And the one that we're going to use to test our installation is the utilities directory, and we're going to go into device query. And we're going to want to open up the VCX project for the correct version of Visual Studio. We have Visual Studio 2015, so let's open up the VCX project, this one, device query, VS 2015, VCX project. So far we haven't associated that with Visual Studio yet, so we're going to open that with Visual Studio. Visual Studio is going to tell us that it's missing some features, and it's going to need to download and install a few more things. So go ahead and hit install on that. This is going to take a few minutes. All right, Visual Studio has finished installing all of the extra bits it needs to compile the CUDA examples. So let's go ahead and close this, and we're going to have to open up Visual Studio again. We're going to need to open up that VCX project. And now we're going to open up this project that we tried to open up previously. We're going to open it up in Visual Studio. This is device query, and it has all of the, this is the C++ file associated with device query, so you can take a look at what's actually going on here. But we just want to test our installation. So let's go ahead and build and rebuild the solution for this. It doesn't take very long. And you're going to see, a lot of stuff's going to go by here. And there's quite a few warnings that we can actually ignore. The important thing here is that you see at the end it says rebuild all. One succeeded, and that means that we were successful at building this. So we can go ahead and now run it. So after Visual Studio builds the CUDA example, you might be wondering, where is the executable file? So here are our sample CUDA samples again, which are under the program data directory, and you actually have to go into this bin directory. So that gets compiled up into this bin directory, and then it's hiding here under Win64, and it's not under release. There's just DLLs in the release directory. It's under debug. So we have device query.exe in debug here, and this is what we want to run. So in order to run this, you're actually going to have to run this from a command window. So just type cmd into Cortana, and you can pull up a command window, and then we just have to make sure we get into the right directory before we run this. So we're in there, and then we run device query. You can just run it directly like this. And this is what you should see. This will confirm that your CUDA installation is correct. This indicates a successful CUDA installation. And if you don't get this, then you should go back and repeat some of these steps so that you can confirm that your CUDA installation is working correctly before proceeding with the Tensorflow GPU-enabled installation. So we've got CUDA working correctly, but we haven't actually put the CUDNN requirement in place yet. We've downloaded it, and we can check in our downloads folder that we have CUDNN version 6.0, and we can navigate into here, and it just says CUDA, and then it's got some libraries and binary files and things like that. I actually would like to change this CUDA to CUDNN. This is optional, you don't have to do this, but this just reminds me of what it is. And then I like to copy this. We're going to go ahead and just copy this folder, put it somewhere in with all my other NVIDIA stuff. So this is my CUDA samples directory. And we're going to put it, let's put it one layer up from the CUDA samples directory. So this will be, I'm going to put it here in Program Data NVIDIA Corporation. And I'm just going to go ahead and paste my CUDNN stuff in here. Let's go ahead and get the paths set up. This is a tricky step, but it's required for TensorFlow to be able to find the runtime libraries for GPU-enabled operation. So we're going to, in the Cortana box, we're just going to type environment variable, and there'll be an option to edit the system environment variables, and you should get a window that looks something like this. Okay, so we want to change our environment variable, so let's click on this, and here's our path, and this is what we have so far for the path. Let's edit this, and we're going to add some new elements to this. So let's put in a new path, and we're going to want to have access to this particular runtime library file in cudnn. So let's go into cudnn and drill down into the bin directory, and you can see that there's cudnn 64_6dll. That's what we want. So we want to copy this path. So copy it as text, then switch back to our path editor. We'll put a new one in here, and we're going to paste it. So we're going to keep that there, and we're going to add one more thing to the path, and this is going to be the path to the another runtime library in CUDA. This is the default installation location for some runtime libraries for CUDA 8.0, and we're going to want to add that in as well. So we're going to add two things to the path, one for cudnn runtime libraries and one for the CUDA version 8.0 runtime libraries, like this. And if the second one should apply if you've used the default installation location. So go ahead and hit OK there, and hit OK, and finish out of this, and your path should be all set. So let's install TensorFlow now. There's two ways to do it. They recommend using pip or Anaconda. I personally prefer the Anaconda method, and so I'm going to show you how to do it with Anaconda. Instead of actually using Anaconda, though, we're going to use Miniconda, which is a lot smaller, takes up a lot less space on your disk, and it's going to give you everything you need to get TensorFlow installed. So just Google Miniconda, and it'll take you to this website where you can download different versions of Miniconda. We're going to want the 64-bit installer with Python 3.6, so go ahead and click on that, and that'll take a few seconds to download. This is much smaller than downloading the full Anaconda distribution. Let's go ahead and click on Miniconda and install this. And I'm installing it just for myself. Go with this default location. Just go ahead and install. Miniconda installed successfully, so let's finish this up. We don't need to learn any of these things. And that's all you see. So we're going to be installing TensorFlow with Anaconda, and so we're just going to do a conda prompt here. We're going to type in Cortana, we can type ANA or Anaconda, and we're going to end up with a Anaconda prompt. And what we're going to do is just follow the steps on the TensorFlow installation instructions. So go ahead and hit that. It's going to go out to the internet and start downloading all the stuff that it needs to do this install. Alright, this is what it should look like when everything's installed correctly. Now you can go ahead and activate TensorFlow. We're going to want to make sure that we install the GPU version of TensorFlow since we went through all that work of installing CUDA and testing that installation. So we want to do the pip install upgrade TensorFlow GPU command line. So TensorFlow GPU is done installing. Didn't take that long. Let's go ahead and then validate our installation here. And we're going to just go ahead and type Python. And if you did this all correctly, if all your paths have been set up correctly, you will not get any error at all here. You'll just get a continuation of the prompt. This is usually where things go wrong. If you've done something wrong where you didn't get CUDA installed correctly, or you didn't get, probably the main problem would be that you didn't get your paths set up correctly, you'll start to get all sorts of errors here. And we can proceed with the example that they have here. Alright, after we did this, you can see that we get a bunch of feedback, but none of these are errors. It found a device with certain properties, so it found the GTX 1080. That's great. It's ready to do stuff with your GPU, and we can run this little command here that doesn't really get much advantage from the GPU, but let's go ahead and finish the example, and we'll see that it works. Alright, now that we've got TensorFlow GPU installed, and we've tested it, or we validated it on a very simple example. It's time to test it on something more complicated. And this is where we're going to see all of the advantages of running TensorFlow on a GPU. We're going to get significant speed up compared to running it on a CPU. This is an example that we can download directly from GitHub, and it's on convolutional neural networks. And this looks at the CFAR10 classification problem, where you've got 10 categories of images from airplane to trucks, and then there's already a whole bunch of data available, 32 by 32 RGB images that you can use to train up the neural network. But let's scroll down this tutorial here, and the main thing that you're going to want to get is these Python files. So there's a total of 5 Python files. When you click on these, this just takes you to a GitHub link, and you can download everything from the GitHub link. I have already downloaded all of these files, and I have them in a directory in my on my desktop here. So you can see I've got all these files, and this is what we're going to be running in TensorFlow. So we're not going to edit any of the CFAR code. We're just going to go ahead and run it as it is. And the first thing we want to do is launch and train the model. So we're going to do that by running Anaconda. So you want to get to an Anaconda prompt. We only installed Miniconda, but you can type Anaconda into the Cortana box. You'll get an Anaconda prompt. Then make sure you go to the directory that has all of your Python files in it, and make sure that you activate TensorFlow, right? Because we want to be in our TensorFlow environment when we do all of these things. So the first step is just going to be to run Python CFAR10 train.py. So I've skipped the download. It's finished downloading all of the images. It had to unzip that file, and then it's got to put some images into memory before it can do the first iteration. All right, it took about a minute probably for the first iteration to complete on my computer, and now it's running, and you can see that it's stepping through it's stepping through all the iterations of training the neural network on how to classify these 10 different types of images, and you can see it's running very fast. I'm getting somewhere around, on the average of maybe 6,000 examples per second, maybe a little bit more in some cases and a little bit less in other cases. And you can see this loss function and a step counter and the time of each of these iterations. So this would be much slower. If we were running on a CPU rather than on a GPU, these would all be could be even 100 times slower. So you might be getting something like 50 or 60 examples per second instead of 5,000 or 6,000 examples per second. So this is the type of performance you should expect on a GPU. All right, our neural network has been training for a few minutes now. We've been watching these numbers go by. The losses have been getting smaller. Everything looks like it's running pretty well. But this isn't a particularly exciting way to watch a neural network train. What we'd like to do is see some kind of real-time graph that shows us how things are performing, if things are getting better. And so we're going to use something called Tensorboard to do that. Let's go ahead and open up another Anaconda window. So we can't run it in the same window while the training is happening. We have training going on at the same time. And let's go to the root directory. Let's go ahead and activate TensorFlow. And then we're going to type Tensorboard. And we can't just type Tensorboard. We actually have to point Tensorboard to a log directory. So we need to give it an argument called logdir equals. And the question is, where is this data being logged from this CFAR example? Well, it turns out it's not being logged in the directory where you actually store the Python code. It's being logged in another directory right off of your root directory on your C drive. So on my computer, it's being logged into the directory TMP off of the local disk C. So if you go in here, you'll see that we have CFAR data. That's not what we want. We have CFAR train. This has got all of the logs from the current training process. So this is the directory that we want to point it at. It's going to be temp CFAR10 train. So let's go back to our Anaconda window here, put in temp CIFAR10 train, and hit enter. And now It may give you a couple warnings about some things, like maybe there's multiple log files or something like that. Don't worry about that. What we're going to do is the important thing here is that we're going to go to port 6006. So we're going to just use, this is localhost. This is running on our localhost. We'll go back to our browser and we'll just say localhost and make sure that you have :6006. Hit enter here and Tensorboard will load. And it will show you some really interesting graphs. And we can see here total loss 1. It decreased very rapidly in the beginning, and now it's sort of still smoothly decreasing. And total loss raw, which is not a smooth version of it, you can see a little bit noisier. It's not always decreasing. It's kind of bouncing up and down as it trains on the data that's been provided. So this will be updated live as you let the neural network train. So you can bring up your Anaconda prompt here, and you can see that the neural network is training live, and you can see in the background the Tensorboard is updating live, and so you can kind of track the convergence of your neural network training, and you can terminate the training when you think it's done. If you don't terminate the training, as far as I know, this will continue to run indefinitely. I let it run, I think, to 100,000 steps in the past, and it just seems to continue on. So if you want to terminate that, then just go ahead and hit Control-C, and it'll throw a whole bunch of errors, but the training will be done. The log files will still be there, and then now, of course, the Tensorboard won't update anymore since you're not continuing to train. All right, so that does it. Basically took you through the whole process of getting CUDA installed, getting TensorFlow installed, making sure CUDA was working correctly before we set up TensorFlow GPU, running TensorFlow on the CFAR examples, and then visualizing the performance with Tensorboard. I hope you enjoyed it.